Okay, hi everyone, back again with another video, and in this video, as I said, we'll be doing the server part of the program. So let's just go take a look in here, and I think I have everywhere the way I want it for this particular part, so I think we can just jump straight into the server. We don't really have to fix anything from the last video. So what we'll be doing is we have to create a new project because I think I mentioned that the server will be a separate project. So let's just do that. So we have a separate server project, and then we could have, and then this program right here, the skull, will be an actual client, one of the server clients. So okay, so let's just create a normal project. Yeah, console application. Let's just C++ as usual, and then let's create it inside this. Actually, let's create it inside the skull folder. Actually, so I'm basically creating it inside the project, our previous project. I will just call it server. Okay, so that looks good. Oh no, and I wanted to create it in a directory called server. That's what. Okay, I'm maybe getting here. Let's create a new folder called server. And we'll create it in there. Okay, so if everything else as default. And in the main.cpp, I don't think I'll be objectifying this code much. I mean, it's only a server. Like, I think a good reason for objectifying code and put it in the class is like if there are multiple components of the thing. Like for example, these application, the main application, it has an OpenGL part, a windowing part, which is kind of separate from that. Then it will also have a networking part, which is what we have to add to it after we finish the server. And it has a couple of different parts that we think it should be objectified and stuff. But for the server, it's literally just a server, and it will be, you could fit all the functionality in here, and I don't think it'll be too confusing to have it in one thing. So let's just go though. So remove this default stuff and let's include what we'll need. We'll need, for me, I need stdio. I don't really care if you use IO stream or whatever. Okay, and next we'll need wingsock, the actual wingsock library. This is what contains the networking stuff. So wingsock, it should be in your core blocks directory, so nothing you have to go and install. Next we want to include thread. We need to use threads because a lot of stuff in networking is kind of blocking unless you really don't want it to be, but yeah, sometimes it blocks the entire thread from running, so we need to use threads. Okay, and that's really all I think we want to include for now. So let's set up a couple things right here. Let's remove this nonsense, and then let's just define something here. So let's define localhost. Define something called localhost. We'll define that to be 127. The string is a string, by the way. 127.0.0.1. Okay, and next we'll define something called IPv4 because the name of it in the library is a little weird, so I defined it myself. So hash define IPv4, and this is just the protocol version 4. We're not going to be using version 6. The name of it in the library is called AF underscore inet, and it's just a little weird to me, so I just defined it myself. Okay. So next we want to set up something. Basically everything in networking is just a message. And we just want to know. We basically just want to know what type of message it is. So we'll basically set up an enum. Whenever we're sending or whenever we're receiving a message, we first have to receive what type it is. It could be just a message. It could be the actual image itself. Or we didn't name it enum class. And it will be called message type. And the first one will be called message, like a string message. I'm gonna just call it string message, actually spell out the whole thing. And then the next one could be an image, a frame message. And I think that's all I want for now. We'll just explicitly set the first one to 0. Okay, and then next we want to set up. For now, I'm just going to limit the amount of connections. So we're going to set up an array. If you didn't want it to be set, you could just use a vector instead. But I'm just going to limit the amount of connections to 5 because I don't need any more than that. And socket is the name of the the socket holds the connection between the server and the client. And we'll create 5 of them. I'm just going to define something called map sockets or something like that instead of just typing 5. Okay, map sockets with an S. And now after that we'll just, well, actually let's just go into the main function. So in here, as usual, we cannot start before doing this. We have to do printf hello world. Hello world. And let's just put a new line. Okay. So next there is a these older time libraries have some like weird startup things. Like for example, this one to me is pretty weird with startup. So let's create. There's something called WSA data. I have to create one of those. I'll just call it this because I don't plan to use it anywhere else really. This is used for startup. We have to create something called a word. A word is just an unsigned chart, as you can see, but Microsoft just has to name stuff weird, and then it's going to be called the DLL version, and then we're just going to set it equal to make word. This is a macro. I don't even want to get into what it does. So there's version 2.1, 2,1, not okay. That's good. No need for the extra parentheses. And after that, I think we just have to actually do the startup now. So and we have to check because it's something that could fail. FWSA startup. Okay, so as I was saying, FWSA startup. Then and it takes in the DLL version, and it also takes in the memory address of the WSA data. Okay, and if it returns 0. So if it does do, then message. We're just gonna print f failed to start failed to start Wingstop. And new line for sure. And I'm not gonna exit. As you probably noticed that I don't exit the program when we get an error or just print f something. Okay, so if that goes fine, then we don't need to do anything else with that. We've done the startup, and now we can like completely forget about it. So now it's called something called a sock addressing. This, and we're basically setting up the binding address. So this is what determines what the server listens for. So you could set it up so it only listens for connections on localhost, or you could set it up so it listens to anything. Let's just do this thing right here, where we do define localhost. Just let's define something called any host, and we'll set it to 000. I'm not going to use it right now, but it's just nice to have it there. And I'm just going to call it socket address. Socket bind address. And we're going to set it equal to 0. just initialize it, and then we're gonna set some of the properties right now. So socket bind address dot s sign dot sin address, and then on, I think this is only for core blocks. The version of Wingstop on core blocks is inside of the variable we want to get to is inside a union, so you have to do s underscore un. Yeah, that is pretty weird. And then dot s underscore address. Yeah, this is the syntax for it isn't so good, like the structure, but okay. Then we want to set this to a net address, and you want to use the localhost. This is for the binding address. So we're setting up. You're basically just setting up the binding address right here. Localhost. We just define that. So it only listens for connections on localhost. Next, we have to do the port that we want to listen on. We should just choose something that we know isn't really going to be used by any other program. SIN port. Okay, and we're going to set and we have to use a function called H2N, which stands for host to network. H2NS, host to network. I think it stands for host to network sign or something like that. And for the port, let's just define the port as well. Hash define port. We could use like port, I don't know, 2000 or something like that. I'm just going to use 222. Let's just see if that conflicts. Hope it doesn't conflict. Okay. And again, we have to do which type of IP addresses we'll be handling. And as I said, we'll be using IPv4. Socket bind address dot sign family equals IPv4. It won't be defined. Okay, and that looks good. Okay, so we have to get the size of the address. We'll just store it in an int. We'll call it address size. It's just like the same weird stuff here. We have to get the size of the structure before we use it. So address size. And we just do size of the same variable, size of socket bind address. Okay. Next, we want to do. No, we actually want to listen for connections. So let's just set that up. So we have to create a socket. This is the socket that will listen. So the socket can either be in two states. It can be a listening socket or just a normal socket which just connects and does communication. So this one is going to be listening. Socket called listener. We're just going to listener socket just to be very clear. It's going to be equal to socket with lowercase socket. And it takes in the address, the type of thing you want to listen to, so IPv4. Then it takes in what type of like how we'll be listening. It'd be something called sock stream. Then the last part takes in what does this take in again? I'll just pass 0. I think it's if it wants to be blocking or something. Next we need to bind the socket for listening, so just bind it. So what we need to do is pass in the socket we're binding, so just create a listener socket. And then next it is saying the same socket binding address we set out earlier, so socket bind address. Socket bind address, and we have to cast this to a socket address. Yeah, we have to bind it to a sort address, not a sort address in, but yeah, it's supposed to be a sort address in, but we have to cast it in this function. And then after that, it takes in the address size that we got right here. So address size. Okay, and then we actually just have to listen. We have to place the socket in the listening state. So just listen, and then the socket, it should be listening socket, listener socket, and then the type. And then it takes in a sort of flag right here. So SOMA. So this stands for socket max connections. Socket max outstanding connections or something like that. I don't really care about that. Next, this is where we're going to start actually connecting to clients as they request. So let's just create a socket out here. There's going to be a loop, by the way. Let me make it clear. So there's going to be a for loop, and we're going to do in I equals 0. I less than max connections, then max sockets, sorry, I plus plus, or plus plus I if you guys are specific about that. So in here we'll be using the socket. Let's just create the socket up here above this, and we'll call it connection. So let's call it new connection actually. So right above the for loop, we'll just create something called a socket. So above the for loop, we'll create something called a socket. So not solid address socket. And we'll call it new connection. And this is going to be for each connection. We're going to reuse this same variable because we don't want to be reinitializing in the loop. We're just going to initialize the things inside of it to 0. Okay. And for in I max sockets, we're just going to actually listen for the new connection. So let's just go about doing that. New connection equals to @set. @set is a blocking thing. It actually blocks the thread, so the thread will be actually here waiting. So that will be including thread. We have to handle these things on another thread so that it wouldn't block. So because when this blocks the main thread, we can't be waiting on this. So let's just continue @set, and it takes in the listener socket. It takes in the sock address thing, the sock binding address, the memory address of it. We just have to cast it to a sock address pointer. So address pointer, and then taking the memory address of socket bind listener, socket bind address, and then it takes in the actual address size, and it takes in the memory address of it too. Okay, so that looks good. And then it's something that could possibly fail, so we're just going to check if the new connection is set to anything. If new connection, but it can return an error. If new connection, then remember we have an array of connections that here called connections. So we're just going to set connection sub I. We're going to set that equal to new connection. Okay, I think that's all we want to do. And then we could just have a little message to know it happened. So we're just going to print F above here. Print F client connected. Okay, and we could just send a little message over to the console. We could just send a little message to ensure it also happens. So const char message, const char pointer message equals hey from server or something like that, all caps. Then after that, we actually want to we're not going to send this message yet though. I'm just gonna Actually, I forgot we actually need something to keep track of the counter from externally. Yeah, we need something to keep track of the counter externally. So we call it int. It's going to be another int connection counter, which is just going to be set to 0. And every time we go through here, we're just going to do connection counter plus plus. And then the next part is pretty important. We have to create a thread because, as I said, this is blocking, so we have to create a thread to handle each connection. So we can do socket bind address. Well, no, not socket bind address, sorry, std thread. And we're just going to create a thread. We don't have a function yet we're going to be calling, so we should probably create that. So we're going to call it client handler thread. That's just called declare it out here. You could probably define it too. Client handler. And we're just going to define it. It's going to take in an int, which is going to be the same as I right here. It let us know which one it is. It's sort of an ID. So int ID. Okay. And in here, all we'll do, well, you don't even have to do anything in here for now. Okay, so let's just pass in the client handler. Did it define the return type? No, it didn't. So it's void. And we're not going to call the function, so remove the parentheses. And in here, we're just going to pass in the after the thread takes in the function you want to call, and then it takes in the arguments you want to pass to it. So if you want to pass I to it, that's going to be kind of the ID. And then here is where we're in a problem, because as soon as the F statement, it exits the F statement, it's going to destroy the thread. So what we need to do is either create a new thread, but this could cause a memory leak of some sort. So what we actually have to do is detach the thread so that it will no longer be late. After you detach it, it's kind of like unlinked from the main thread, so now it won't get destroyed as soon as you this variable here might get destroyed, but we don't really care about it anymore. It's just going to be a thread running on its own. So yeah, that's what we want. Detach. And I think that's all we need to do in here. And we need to handle the case where connection is not true actually, because we're checking for a connection right here. So let's just do that. We're just going to printf new connection field or something like that. Okay, that's it. And because we're not even going to return anything from the main function, and this is the for loop here, so after we're done with that, we just want to do something called while true, because after we reach the max connections, it's just going to quit the program. So if we don't do this, I would like to just okay, yeah, we're just going to do while true if nothing is like. But I heard that this can be kind of, it can like take a lot of CPU usage. So if anyone knows a way to just to do this without this taking up so much usage, then let me know. Okay, so what we actually do now is define this thing called client handler. There's a couple things we need to define actually, but we'll just define this first. Then we also need to define a function for sending a message. Then we also need to define a function for getting a message, and then one for sending a message type, all that kind of stuff. So let's just get started here. Define the client handler. The client handler will just have something, a variable in here called a packet type. Not packet type. They have a variable in here called message type. Remember we created those things. Message type. Okay. And it'll just be called message type actually. Okay, we won't set it to anything by default. And then go through. And so this is just going to run for the duration of the entire program. So go through. We're just going to do something called get packet and get message type, sorry. And it'll basically have the ID of the socket. So we're going to pass in the ID. It's going to take in the in. I'm just defining some of these, like basically using some of these functions before we have them defined. So yeah, and then it taking message type as well. It's most likely going to be by reference. We want to get the message type and then process the message. Process message. Okay, and then it's going to also taking the ID and the message type again. Okay, and we can also these will return something, let us know if it worked or not, so we could check for them. If not, message process message. Then just print F. Fail to process message, and we'll also do the same for get message type. F not get message. Then we'll just print F. Print F. Fail to get message type. So now what we actually have to do is actually go define the two things we just using here. We want a way to actually get out of this, so to get out of the while loop. So we're just gonna, in the case of one of these, we're just gonna break. In the case of we can't process the message, we're gonna break, and then we're gonna go into we're gonna break, and then we're just gonna close the connection. So it's called close socket. And then remember we have an array of connections called connections, so that's the one we want to close. And the ID, remember the ID is kind of like the index as well. So yeah, we're gonna pass in the ID. So yeah, that's pretty much, that's gonna work out pretty fine. You know, we want this outside of the while loop. Okay. Okay, so now we want to define these two things out here, the process message and the get message. So we'll go even above that. And they're going to return booleans because remember we're checking for them. We're checking if they return something. So let's first define get message type. Get message type is going to be a bool. Okay, and it's going to take in the ID, the end ID. Oh yeah, and it also takes in the message type. It didn't take it in by reference, by the way. Message type by reference. Message type. MSG type. I'm just gonna be lazy. Okay, and after that, let's just do. This is what we're about to see the function that we use to receive things. Int check, int success. Well, no, we just call it check. Int check equals, and this is the function we use to receive recv. And then we'll pass in the connection that we want. And remember, we have the array of connections. We're using the ID as both. It's an ID and also the index into the connections array. Connection sub ID, sorry. Next, it takes in the thing you want to store the data that you're receiving in, which is the packet type. So we have to cast it to a char pointer. Okay, and then it takes in message MSG type. The memory address of the MSG type, by the way. So we're kind of type one in there. So size of the last parameter is of course the size of the packet thing of the message type, MSG type, size of MSG type, and be sure to use the full word size of. Okay, and the last one, sometimes it's hard to remember what the parameters are because this thing in code block doesn't have the name of the parameters, but can't remember what it is, but I know it passed 0 here and it's fine. So okay, so let's see if it was successful. We're going to check this thing right here called chat. F chat equals socket error. If it equals socket error, then we just want to print f fail to receive message, and let's just do the name. Otherwise, then we'll also return false because remember this is a boolean. And then otherwise we'll just return true to let it know it was successful. Okay, and then we want to go define process. We will call it process message right here. It's going to be a bool as well. Process message, and it's going to take in the ID and the int. It's going to take in the ID, so int ID, and also the message type. This one doesn't really have to be by reference, but we could still do it by reference. Message type, MSG type. Okay, so inside here, all we'll do is there's going to be a char pointer because remember even an image is a char pointer. It's going to be called message. And then there is going to be a switch statement which will determine the packet type. So let's just switch the packet type, the message type, MSG type, and there's the case where it's going to be equal to just, well, let's see the type. We have string message and frame message. Let's just check for both of those. And where is process packet? Oh, process packet, process message. I mean, case message type. Okay, I don't seem to be getting it. Pretty sure this is how you use it. So case message type equal to string message. We just wanna, when it's equal to string message, let's make sure we break because that has caused us problems before. Okay, so in that case, we just wanna get the string. This is when we're receiving it, by the way. The server is receiving it. So just receive a string. There is going to be a separate function called get data. This is will get whatever the person is sending. Let's go define that right now actually. So get data, and then it's going to take in the ID, the int ID, and then it'll take in, and be sure to declare all these things below the connections variable right here. So it's going to take in the ID and just also the packet, the message type. Well, not the message type. This is going to be it's going to take in the pointer to the message actually. So char pointer, message. Now what we need to do, we also need to pass the memory address of the pointer, the message pointer as well, because then maybe try to assign it to something it will fail otherwise. Because even a pointer is passed by value, not by reference. So yeah, it's kind of weird, but yeah, we have to do that. Then in here we'll just create something called data size. because it's going to be the size of the data that we are being sent. And we're just going to leave it uninitialized. And then what we need to do is use another function which we have to define, but it's going to be called something get size. It's going to take in the ID and taking a variable to store data size in. We'll pass it by reference, so we don't need to use memory address. Okay. What? Okay, so that should be good. And we're going to check it. Everything we're going to do is going to be a check because networking is kind of sensitive like that. You have to always check. Okay. We can just return false. This is going to be a boolean. Oh yeah, get data is a boolean as well. Return a boolean. Return false. And let's not forget to printf some useful message. Printf fail to get size. Oh, it'll be called get size. Sorry, size. Fail to get size. New line. Okay. And let's go define get size before we forget. So it's going to be a bool. Bool get size. It's going to take in the int ID and the actual thing we want to store the sizing. So that's going to be an int reference. Data size. I'll just call it size. Well, data size. So it won't be green. Okay. Int chat. We're just gonna see we're gonna be receiving again from the we're gonna be receiving again from one of the clients. So we use rec here, and we always check because networking, like with most other types of thing, you could probably get away with not checking, but networking you probably should, unless you're doing like a game thing where you don't need all the data. You can live without receiving some of it, so you don't have to check. But for this kind of stuff, you should. Directly we are going to pass in connection sub ID, because remember the ID is also the index. Okay, as usual, the thing to store it in, which will be data size, the memory address of data size. We have the cast to a chart pointer, memory address of data size. Okay, and now the size of the actual thing, so just it's going to be size of int. You could probably also pass in size of data size, but we know it's going to be an int. And then again, we just pass 0 for here. You can't remember exactly what that parameter is. Okay, and if it thinks, then it'll just return false. If it's not, f check equal socket error, because I don't think it returns 0. Or as you can see, it returns -1. So we have to check explicitly f is equal to that. We're just gonna print f and then return false. Fail to get size, and then return 0. Return false. Sorry. Okay, and then otherwise we'll just return true. Okay, so we have get size, and that's working. It should work. So let's just go back down here to get data. Actually, I'm just gonna call this get int. It's not necessarily going to be related to size. We'll just call this get int, and then what I'll do is define something called. I'm going to define something called get size to get int. Okay, and that should be fine. So yeah, we shouldn't have to do anything. So back in here where we're defining get data, after we verify that we did get this thing, that we did get the size, we can actually go ahead and receive it. So after we get the size, we actually want to allocate a buffer big enough to hold the thing we want. So remember we just passed in this message thing. The reason we needed to pass it in by the by pointer reference, we need to actually edit the pointer itself. So data equals new size. It has to be the same the size. I can't remember if you put the array brackets right here. I don't think you do, so I'm just gonna remove it from there. It's gonna be equal new char of that size. I think that's the syntax for it. And then we're just gonna add one. We should probably add one, yeah. I'm wondering if we should do it. Yeah, we'll just add one. Data, and then we're just gonna make sure. Oh yeah, we called it data size, by the way. And then we'll just make sure data size, data sub, the last, we'll just make sure the last one in the char array is equal to a termination character. So let's just make sure the last thing in there is equal to a termination character. /0. Okay. And we could delete this as well after. So let's be sure to delete it. Actually, we don't want to delete it in here, actually. Sorry. So yeah, I think this is all we want to do. Actually, just... Oh yeah, we actually have to receive it too. Oh. So we're just going to check directly for the... We're not going to use check or anything. We're not going to create a array. We're just going to do recv f equal socket error. Because we don't want to do it right now. Socket error. And then, of course, the connection sub id. Then the thing we want to do, it's already a char pointer, so we don't really need to do anything. It's going to be called message. Oh yeah, this is supposed to be message, by the way. You could probably call it data, but yeah, I could see it getting confusing because we're calling it data size, but then we're calling the same message. But anyway, it's taking the actual message, and since it's already a char pointer, we don't need to do anything really. And then next, it'll taking the size of the thing we're receiving. Data size. And then, as I said, I'll just keep sending that to 0. And then f it does equal socket error. We'll just print f. Print f failed to get message. Return false as well. Otherwise, we'll just return true. We already have everything we need because we are passing these in by reference. So the message will already be set. Return true. Okay. And we can just define get data to be get message. Define get data. Get message, sorry, to be get data. So we can use something that makes a little more sense. So in here, in process message, we want to just do what we just did, get data, get message actually. I guess we're not going to check for it. Well, we could check for it, yeah. So f get message, f not. Then let's just return false. Okay, and that should be okay. So this is when it gets the message, and after that, what we want to do is just remember this will be the message from one client. So after you get it from one client, you want to send it out to all the other clients which are connected. So we'll just do for int I equals 0, I less than. This is where we need to keep track of the connection counter. Remember I added this, so we'll just it's less than connection counter, not max. Because remember we have a limit of 5, but there might not be 5 people connected at a time. The connection counter is what lets us know how much are connected. Okay, it's less than that, we just do I plus plus, and we're gonna go through all of them and actually send them the data. So we're not gonna use the send function directly, the one from Wingstop. We're gonna create our own thing called send message, and we're just gonna define that right now actually. Oh yeah, we want to skip. We don't want to send it to ourselves. Well, not to ourselves. We don't want to send it to the body that just sent it. So we're just gonna make sure we skip them. So if I equals to equal ID, then we just want to continue. Okay, that's all we want to do. So we now have to define something called send message. Let's just go above. We'll just go right here. I don't want to go too far. So send message. It's going to be a bool. Send data actually. And then we can define send message to this. It's going to take in as usual the ID. Then it's going to actually take in the message we want to send. So we'll just call a char pointer call message. It can be a const char pointer too. Not really necessary, but we'll just make it a const char. Okay, and then to the definition. So there's basically going to be an unsigned int called data size. Although we probably should pass that, we did get the data size in some other place, but we'll just do strlen because remember it's a char pointer. So we could, and we're explicitly setting the last character in there to be a termination character. So strlen should be able to handle it. So I've been calling it an int all this time, so let's not change. No, I'll just do unsigned int, and it's going to be called data size. And then it's going to be strlen message, which by the way could be a frame or image. So yeah, strlen message. Strlen is that inside? We aren't including string though. Is that inside one of these other things? Okay, I'll just roll with that. So here is send data. So we want to send the packet type. Remember, we want to send in message type. So we have to define something called send message type. So we just define that here. So it's going to be a bool, as everything is send message type. And I'm just defining the variables as we need them. So I think it kind of maybe helps you understand why we need this and why we need this function. Because if we were to just define all of them beforehand and then use them, like I think you could get confused as to why we're creating all of them. But either way, I hope this doesn't mess it up too much. So there's going to be something called send message type. It's going to take in, as usual, the ID. And then it's going to take in what type of thing you actually want to send. So, okay. Oh, I think this here is supposed to be capitals. Yeah, in the enum, we're calling it string message. So yeah, randomly just fixing this. So the message type. We're going to take it in by, we're not going to take it in by reference, it shouldn't have to. MSG type. And then inside here, we're just gonna, this one is gonna be pretty easy. Instead of, so we're not receiving anymore, we're actually sending, so there's a separate variable for that. We'll just do ink check equals send. This one is more sensible, it's called send, and it takes in the socket we want to send to, so connections sub ID. It takes the thing we want to send, which is going to be the size. Well, not the size, the actual type of message we want to send. So it's called a cast to a chart pointer, remember, and it's going to be just message type, the memory address of message type, MSG. Okay, and then next we're just taking the size of packet type, size of the message type, sorry. And then that will pass for here 0. And then we're just going to do f check equals socket error. Then just print f failed to send type, failed to send message type, and then return false. And then after that, and then if it does thing, we'll just return true. Okay, so in here we'll just use what we just created. So we'll do f not send packet type, send message type. Okay, and it takes in the ID and the message type, which will be in send data. We should also take the type. Yeah, we'll also take the type. Send data message type. MSG type. And we're using this inside get data. Okay, so we need to start from here and then send the message type into the process message as well. Well, we are sending it in there. So inside process message, inside here, inside get message, and then inside here is where we need to pass it. We'll be using it here. Okay, so MSG type. Okay, that looks fine. If that is not the case, then we'll just return false. We already have a message printing if it does fail, so we don't need to print one again. And then we just have to send the size. After we send the packet type, after we send the message type, we have to send the size. So again, that's something we have to define. Bool send size. We're just gonna call it send int, and then we'll just define it. Send int. And we might have to change around some of the order we are defining these things in case they depend on each other, but it might be fine. And of course it takes in the ID, and then it takes in the size, the actual size we want to pass. Okay, and then the actual size, int size. Well, we'll just call it data size. And as usual, we'll just send the thing. I think I just want to copy this actually. Then it's going to send data size instead. Size of int. Okay, and then yeah, everything else should be fine. Yeah, so let's just go use this. We have to define it too. Sorry about that. We have to define it to get to send size because we call it send int right now. We want to define it to send size. Define send size equal to send int send size inside the send data thing. Send size. And then we're just passing ID and then the actual data size. Okay, that should be fine, and then we'll just return false if it doesn't do this. Okay, and then lastly we actually want to send the message, and that is what the function is for in the first place. So after all that, if everything is good, then we'll just send directly. So we'll check for the send. We'll just check in here in the CMS statement f equals socket error. Then we're just gonna pass the socket we want to pass to connection sub ID. We want to pass the actual message, so message. Then we're gonna pass the size, which yeah, this is already a char pointer, so we don't need to do anything there. We're just gonna pass the size of it, data size, and then 0. If it's equals socket error, then we just want to return false and printf failed to send message. Return false, and above the return, printf failed to send message, failed to send data. Okay, and that's it. And let's define send message to be. So let's just define send message to be send data. Okay. And then here in the for loop where we send it to the other clients that are connected, we're just going to actually use it now. Okay, so we're just going to actually send. We're just going to check for it because it does return something. So send message ID. The ID is going to be I in this case. The message itself, which will just be in the get message thing here, we have to pass in what we want to put the message into. Don't forget that. So ID, we want to get it from that thread, and then we want to pass in the message thing here. Okay, and then it will that will set message to what we want. So we just have to pass. We just have to send it in here. Send it out. Okay. And if it doesn't do that, we'll just return false if it fails to send. Remember, we're already printing messages inside of the actual function itself, so we don't need to print anything. And then after that, we could just print after the console message sent. Although printing, I find that printing can actually be pretty heavy, but it could just be because my computer is shit. But this shouldn't be happening too regular. Send message sent, new line, okay. And then we want to handle the case if it's a frame. We call it frame message. Case frame message. Well, message type. Frame message. That's what we call it, right? Yep. So the case of a frame message. So this is fine. In the case of a frame message, we barely want to do the same thing, but we're more likely to be getting the resolution than anything. Okay, but this is fine for now. And then we just want to handle the default case. which is just going to return. Well, in the case we do get something like this, we're just going to print F, because that means we don't know the packet type. Unknown packet type. Unknown message type, sorry. And then we're going to break. We don't have to break really. We'll just return true after all of this, after the switch statement. Return true. Now we don't want to return false here, because remember that's what we're, if it returns false, it'll break and it close the socket. So yeah, this is fine. This should be fine, sorry. So let's just compile and see what happens. Let's just compile. We won't run. Let's just try to compile. Inman is supposed to be enum, sorry. And that's probably why you weren't getting these suggestions. So let's go back down here and see if we get suggestions for this. Okay, yeah, we do. So that's okay. So let's just try to compile again. I'm not getting this one. What? 2 or more data types in declaration of connection counter? Huh. I've never seen this one. Okay, I think it was just because it was forgetting the semicolon after enum class. So no error expected equal. Oh yeah, I used 3 equals here. So I'm playing JavaScript, still remembering JavaScript. Semicolon. So send message, or we have to send the message type as well. MSG type. And then we have to forget another semicolon. And then here we have to send the message type again as well inside send message. Okay. And yes, another semicolon. Size of. I think we need to cast this to a pointer, and then yeah, this is supposed to be a pointer. Cast it to a pointer, the memory address of that. Okay. Do we need to link something? Okay, so it looks like we need to link something. So let's just go in our server project properties, and then inside projects build option, linker settings. Let's just add something. Let's just go in here into the program file, x86 code blocks, mingw lib, and there might be something here having to do with that. wsock32. They think this may be it. No, I don't really want to keep the path as relative. So no. Okay. Let's just see if that was the problem. Okay, so it actually compiled, guys. I think I'm just gonna end this video here. It compiled. It doesn't make any sense running it really. It won't do anything. It's just gonna print hello world. So yeah, I'm just gonna leave this here for now. This is basically part 1. In part 2, I'm just gonna I think I'm just gonna do the client. Go back in this project right here in C Skype, and then we're actually gonna set up a client here. So okay, I think that's it for this video, guys. See you guys next time. And oh yeah, guys, just one last thing. Look, I forgot to return from one of these functions in the send message, in the send data. I forgot to return. So if everything works, so we just want to return true. Okay, so that should be it now. We shouldn't get that warning anymore. Okay, and then we have the unused variable. We'll just leave that there for now. And that should be it.